In this session, we'll be looking at computing normal probability with focus on how to compute probabilities from the normal distribution and how to use the normal distribution to solve problems. Just a quick recap from our last session, we saw that in order to convert a normally distributed variable x to a standardized normal variable z, you will subtract the mean of x and divide by standard deviation as given by the following transformation formula. The mean of z distribution is always 0, while the standard deviation is 1. The value above the mean always have positive z values, while those below the mean values are negative. One of the properties of the normal curve is that the area under it is equal to 1, so that one can estimate the probability that a randomly selected case will have a score that falls in certain range. These probabilities can then be found as area under the curve. The probability for the interval is given by the area under the curve above the interval. Note that the probability of any individual value is 0, so that the equal sign in the interval can be removed. Since any normal distribution can be transformed into the standardized normal distribution, we can find areas under any normal curve from a single table called the standard normal table or normal curve table or z-score table. The table entry for each value z is the area under the curve to the left of z and ranges from minus 3.49 to plus 3.49. The table allows one to look up values for probabilities or percentages of a population expected to score above or below the obtained z-score. The first step in reading the z table is to locate the z-score on the table. The table only shows value for z-score to 2 decimal places. Each table row is for a different z-score to the 1 decimal place. Table column shows the 100th place. Suppose we want to find the area of the z-score for 0.81. We find the row label 0.8 and then we move along that row to the column label 0.01. The number in that cell is the area below the z value. This is 0.7910, which is 79% of z-score are less than or equals to 0.81. To compute probabilities when a variable is distributed normally, the following 3-step procedures are recommended. The first step is to sketch the normal curve for the problem in terms of x. Secondly, use the mean and standard deviation and the value of interest to translate x value to the z-score. Finally, use this z-score to determine the population that lies to the left of the value of interest by using the standardized normal table. This is the value that is usually required to answer most questions. However, you will need to interpret the question properly to be able to use this number. Let's have a look at this example. For instance, if you are interested in normal lower tail probabilities, supposing x represents the time it takes in seconds to download an image file from the internet, and it is normal with a mean of 18.0 seconds and a standard deviation of 5.0 seconds. You wish to compute the probability that x is less than 18.6. We will follow the three-step procedures discussed earlier. First step, we sketch the normal curve for the problem in terms of x, where the mean is 18 and the value of interest is 18.6. Second step, we use the mean and the standard deviation and the value of interest to determine the z-score using the z-score formula. So if we substitute the mean value, which is 18, into this equation, the standard deviation, which is 5, and the value of interest, which is 18.6, we will have a z-score value of 0.12, so that we have a one-to-one mapping between the x values and the z-score. Finally, we use this z-score to determine the probability from the standard normal table. On your table, first go to the first column and find the row label 0.1 as shown in the small portion table here, and then you go to the column labeled 0.02 and find the number 0.5478, which is the area that lies between the z-score of 0.12 and the tail end of the curve, as shown in the red portion of the normal curve here. So the probability that z is less than 0.12 is equals to 0.5478. Suppose we wish to find the normal upper tail probabilities. In the example that we just treated, if our interest is in the probability that x is greater than 18.6, the steps are similar. First, we sketch the normal curve for the problem. Next, we translate the x values to z's value as we have already done before, putting in the value of 18 for the mean and 5 for the standard deviation. We have z equals to 0.12. Since the normal curve is symmetric and the area under this curve is equals to 1, probability of z greater than 0.12, which is the area between z-score plus infinity, is equals to 1 minus probability of z less than 0.12. Using the value of probability of z less than 0.12 that we had before, which is 0.5478, so we just subtract this number from 1, and that will give us the probability of z greater than 0.12. It is also possible to be asked to compute the normal probabilities between two values. Still, using the time taken to download an image file from the internet example, suppose we wish to calculate the probability between 18 seconds and 18.6 seconds. The steps are the same. First, we draw the normal curve for the problem in terms of x. So this is the lower part and this is the upper part of the question. Then we calculate the z-score for both values, which are 0 and 0.12 as we have done before. Lastly, we use the normal table to extract out the area for these two values. The probability that z lies between 0 and 0.12 is the difference between area corresponding to the two values. So essentially, we just need to subtract the result of the z-score for those two values. So in this case, the probability for 0.12 is 0.5478, and that of 0 is 0.5, and that gives a value of 0.0478, which is 4.78%. To summarize, we have discussed how to compute probabilities from the normal distribution and how to use the normal distribution to solve problems.